Statistical methods in AIML. Descriptive statistics. Definition methods for summarizing and describing the important characteristics of a data set. Examples: mean average value of a data set. Median middle value separating the higher half from the lower half of a data set. Mode most frequent value in a data set. Standard deviation measure of the amount of variation or dispersion in a data set. Variance the square of the standard deviation. Percentile value below which a given percentage of observations fall. Inferential statistics. Definition methods for making inferences about the population based on a sample. Examples: hypothesis testing procedure to test whether a hypothesis about a population parameter is true. Types. T-test compares the means of two groups. Chi-squared test tests the independence of two categorical variables. ANOVA compares the means of three or more groups. Confidence intervals range of values used to estimate the true value of a population parameter. P-value probability of obtaining test results at least as extreme as the results actually observed. Assuming that the null hypothesis is correct. Regression analysis. Definition statistical methods for estimating the relationships among variables. Examples: linear regression models the relationship between a dependent variable and one or more independent variables using a linear equation. Logistic regression models the probability of a binary outcome based on one or more predictor variables. Polynomial regression models the relationship between a dependent variable and one or more independent variables using a polynomial equation. Ridge regression, a type of linear regression that includes a regularization penalty to prevent overfitting. Lasso regression, a type of linear regression that includes a regularization penalty, which can result in sparse models. Classification. Definition methods for predicting categorical outcomes. Examples: decision trees, tree-like model of decisions and their possible consequences. Random forests ensemble method using multiple decision trees. Support vector machines finds the hyperplane that best separates the classes. Nearest neighbors classifies based on the majority class among the k nearest neighbors. Naive Bayes probabilistic classifier based on Bayes theorem. Clustering. Definition methods for grouping data points into clusters. Examples: k-means partitions data into k clusters by minimizing the variance within each cluster. Hierarchical clustering builds a hierarchy of clusters by either merging or splitting them. DBSCAN density-based clustering algorithm that groups points closely packed together. Gaussian mixture models probabilistic model for representing normally distributed subpopulations within an overall population. Dimensionality reduction. Definition methods for reducing the number of variables under consideration. Examples: principal component analysis (PCA) reduces the dimensionality of the data while preserving as much variance as possible. T-SNE nonlinear dimensionality reduction technique for embedding high-dimensional data in a low-dimensional space. Linear discriminant analysis (LDA) finds a linear combination of features that characterizes or separates two or more classes. Time series analysis. Definition methods for analyzing time-ordered data points. Examples: ARIMA combines autoregressive and moving average models for time series forecasting. Exponential smoothing weighted averages of past observations with exponentially decreasing weights. Seasonal decomposition separates time series data into trend, seasonal, and residual components. Profit forecasting procedure for time series data that decomposes time series into trend, seasonality, and holidays. Probabilistic models. Definition methods for representing uncertain knowledge. Examples: Bayesian networks, probabilistic graphical models that represent a set of variables and their conditional dependencies. Hidden Markov models, statistical models that represent systems that are Markov processes with hidden states. Monte Carlo methods, computational algorithms that rely on repeated random sampling to obtain numerical results.